Okay, in this video, we're just going to look at a couple more examples involving solving a 3 by 3 system of equations. In this example, you have three equations. Notice that there are three variables at play here between the three different equations, but each equation only has two variables in itself. Okay, we can solve with a method of our choice here. Both substitution and elimination are able to be used here, but I think this one would be perfect for substitution, okay? I'm going to take the top equation and I'm going to solve it for x, right? X is equal to 3 minus y. And then notice there's only one equation that has a variable of x in it, one other equation, which is down here. So I'm going to substitute 3 minus y into that bottom equation. Okay, so that'll be my first step. 3 minus y plus 2z equals 10. And really the parentheses weren't necessary there. I'm just going to subtract 3 over to the other side. And I end up with negative y plus 2z equals 7. Okay. Now notice that result from step 1, see how it's got the same two variables as the middle equation in the original system. Okay, so that is going to take me right into step 2. I'll take the middle equation and combine it with the result from my first step. So there's my 2 by 2 system. It's already set up perfectly for elimination. If I just use subtraction, I'll get those to eliminate. Be careful here. Z minus 2z will be negative z. And then 3 minus z would be negative 4, making z equal 4. All right, then step 3, we're just going to plug 4 in for z. I probably would do it in the bottom equation. It's going to make x2. And then my fourth and final step, we need y. So why don't we plug 2 in for x in the top equation? 2 plus y equals 3. That means y is 1, making my solution 214. Okay. All right, so you'll notice that all of the examples we've covered so far, both this example and the examples in the previous video, they all had one solution to them, all right? I want to look at a final example that that's not the case, okay? So yet another 3 by 3 system here. We're asked to solve with a method of our choice. And I am going to choose, just kind of inspecting the equations here, I think I'm going to use substitution. Okay, I'm going to take the middle equation and I'm going to solve it for x. And then I will plug that in for x in the top equation as well as the bottom equation. Okay, so step 1, if I plug into the top equation, that takes me here. Okay, distribute your 2. Okay, combine like terms, variables on one side, constant to the other. There we go. All right, do the same thing in step 2 with the bottom equation. Distribute your 6. variables together, constants to the other side. Okay, so notice those two results. They're two equations in the same two variables, both in terms of y and z. And something really interesting happens here, okay? You notice I could divide this equation by 3 on both sides. And what it does is it results in the exact same equation that I got as my result in step 1. Okay, so if I were to go and try to solve that system now, I think you can see what's going to happen. You could just use elimination, and everything will eliminate, right? Gone, gone, gone. I end up with 0 is equal to 0. Okay. Kind of on further inspection, and maybe some of you noticed this right from the get-go. If you look at the original system, okay, did you notice that these two equations are actually representing the same plane? Okay, it's just the bottom equation is in an unreduced form. All right, so the fact that they represent the same plane means they themselves share an infinite amount of points, right? But then there's that third plane to consider. So it's a question of, do those two planes that are the same, are they intersecting the third plane, the one that's in the middle, or are they parallel to it? So if you go back and you look, remember in our first video we had some different examples. So let's see, I think it was example 6. Maybe example 7. Yeah. All right, so example 7, notice it's only showing 2 planes, but really you would be considering 3 planes. It's just of the 3 planes, 2 of them are the same, and then the third, it's intersecting, okay? And then here's the other possibility. There's 2 planes, but really consider 2 of the 3 are the same. Here's a situation where we're going to have no solution because the 2 planes that are the same are not intersecting the third plane, okay? So actually what we have in our example we've just completed is more of this scenario where the 2 planes that are the same are in fact intersecting the third plane. Okay, now how do I know that? Well, it's because I used all 3 equations here in my process and I ended up with that 0 equals 0 scenario. If I had ended up with, a false statement where like 0 equals 5, let's say, then that would be my indication that I'm working with no solution as my answer. Okay, so let's put this back in here and say that this is infinite solutions. All right, that's it for this video.